Welcome to another Video Bites. I'm Ethan Banks, and with me today are Tim Raphael from Nokia and Mark Coleman from NetBox Labs, and we are talking digital twins and how you could build a digital twin with Containerlab. Digital twin is a buzzword, Tim, and if you could share with us what a digital twin it really is, or is from your perspective anyway, and why an operator, why a network operator would care about having a digital twin.
Yeah, absolutely. Digital twins are really super useful. They allow an operator to create a replica or of a portion of their production network and pre-test changes, test ideas, test migrations, anything that might be a large change is worth creating a digital twin. Now, in terms of using Containerlab allows you to run virtual network operating systems. So for Nokia, we have SR Linux and SROS. You can spin them up as containers on your local machine. You don't need a huge amount of server power or anything like that. Uh, and it allows you to build out the topology that matches your production network. From there, you can SSH in, you can use your automation tools, you can use all the sort of bits and pieces you're used to using to interact with your production network. But it allows you to test changes and actually see exactly what would happen if you did that change in the real world.
Okay, so the pieces
One
of
of
the
the
puzzle we have so far here is
Yes,
Containerlab. Containerlab is it's an open source tool backed by Nokia, and I can
correct.
stand up network operating systems and build out a network lab within Containerlab. All right, from
Exactly.
within Containerlab, then the idea is to build a digital twin. That is, let's build a virtual replica of what my network looks like. Let's throw a bunch of routers and switches and whatever in there so that it looks like my network, and then I could use that as a model upon which I could run tests to I want to run this configuration instead of the one I have now. Let me test it first. I could do it in that digital twin.
100%.
Okay.
Yes, exactly. Exactly.
So do I have to build this thing out by hand, Tim, is the question. Do I have to start, dragging, dropping, and standing up all these images and connecting them together? How do I get the thing built?
Exactly. So, yes, you could if your network is small and fairly uncomplicated. However, production networks are seldom uncomplicated. This is where having a reliable and well built out source of truth really helps because, as we're going to show later on today, you can use automation to pull information out of something like NetBox to build that
Aha.
topology for you. We have Mark on the call who might be able to go into a bit more detail.
Yeah, Mark, talk to us about NetBox as a source of truth. It sounds like where you're going here is it's going to save me from having to build out my digital twin by hand because I'm going to be able to use NetBox to do it for me.
That's right. I mean, you're still going to have to build out all that information somewhere. And I want to point out first that actually, the way that Containerlab store their topologies up front is a breath of fresh air. Like it's great for getting started. For anyone who's familiar with, downloading all sorts of VMs and putting complicated things together, it's a flat text file. If anyone's familiar with Docker Compose, it'll be immediately intuitive for them. And it's a fantastic way to get started and start doing experiments. But as Tim said, as you start to get to scale, probably you want to be able to have an easier way to get this digital twin replica of your existing network. And most teams store their existing network L1 through L3 topologies at least in NetBox. So it's a great source for that. And if you like, I can show you how this fits into our automation reference architecture.
We would like. Please show us.
Let me do that. So we've had this out for a while now. We actually created the reference architecture with our design partner program, which is a whole bunch of people from the industry who work with us, not only on the future of what networks should be, but also network automation in general. And what it's intended to show is a sort of very simplified view of how many companies approach network automation when they're a bit further along in their journeys. And there are many other types of useful automation that companies can do before they get to this stage. But the reason why I chose this diagram is because it's really useful for showing the use case that we're going to look at today. In the middle, you can see NetBox, the network source of truth. And like I said before, if you're unfamiliar with NetBox, this is where you are working with your colleagues in your change management processes to make sure that your network is documented in there. From sites, regions, all the way up to racks, devices, even inside the devices, as we're going to see today. And because you're updating NetBox as your network source of truth in your day-to-day operations, it makes a great source for using digital twins to test changes that you're pushing to the network. So where we see the sort of bottom loop down here, where we're seeing intended state from operations going into NetBox, and then that intended state going out to some sort of automation. Typically, companies would like to have some sort of assurances that automation is going to work before it goes to the network. That's not the only use of digital twins, actually. It's really useful for testing out ideas in the design phase before you even get to this stage. But if you are going to push changes out, what better way to get some assurance than to test that network or a subset of that network in a useful tool like Containerlab?
So then, if I have an accurate representation of what my network does look like, or what I intend for it to look like at some future point, then I can programmatically call out the configuration that lives in NetLab. That lives in NetBox and bring it into Containerlab, and then Containerlab There's got to be some middleman. Is this Containerlab doesn't talk to NetBox Labs directly, or does it?
Correct. So Containerlab won't talk to NetBox directly. We rely on another open source piece of software to make this little interaction work. It's called NetReplica. So as is the name, it will make calls to the NetBox API and pull out the devices from the site that you specify. And so it will then build the Containerlab topology and specify the images for each device. So it does the device type mapping for each device type you have in NetBox to a Containerlab virtual image, and it will build that YAML-based text file that you can then use Containerlab to spin up.
Excellent. Well, what else do we need to know before we jump into the demo, guys?
I should probably show you the demo network that we're going to use. So what we're going to demonstrate today is this top line on this slide. So your production network on the bottom, you'd go from NetBox through your config deployment to your production network. We're going to achieve the same thing. So NetBox on the left and the network on the right in our lab example. But what we're going to do instead is we're going to use NetReplica plus the producing a Containerlab topology and then building our lab inside Containerlab. So this just gives you a nice indicator of what we're going to do, but it shows that the input to the process, being NetBox, and the output being network, are exactly the same. So this ensures that your lab testing is valid when you compare it to the production network. It's as close as you can do to testing in production is the idea.
Got it.
So I'll jump in and show the virtual topology. So the demo we're doing today can be pulled down from NetBox. We'll make sure that the URL is in the comments, and your viewers can try this out for themselves. So it's just a simple Git repo with some steps that we're going to follow. There's very detailed instructions on exactly what to do, but we'll run them through here. So first things first, this is the sample network we're going to use. I'll show you in a second that it's all built in NetBox, but we're going to use the pod 1 example here. We'll show 2 super spines, 2 spines, and 2 leaves as just an indicator of the network in terms of the functional capability.
So then the lab itself, we're going to show, you said 2 super spine, 2 spine, and then 2 leaf nodes. So we'll have 6 total nodes.
Correct.
In in 3 tiers. Yeah. Okay.
Yes, correct.
Got it.
There is a fuller example. You could, if you wanted to turn them all into a digital twin, but for the purpose of testing the change we're going to test today, 6 will be more than enough. The whole network uses OSPF, and each pod is using iBGP between the spine and leaf layer. So what we're going to do is, instead of running OSPF across the whole network, we're going to swap the IGP within pod 1 to IS-IS, and we'll show how that can be done without interrupting the BGP between the loopbacks. So the demo will help us explain that.
Very tricky, Tim. Very tricky. All right.
So if we hop into the demo, I've cloned down that Git repository, and we can start by doing a little bit of setup by creating our virtual environment.
And again, Tim, what you're showing us here, these scripts and so on can all be downloaded from that repo you just had up, right?
Yep, exactly.
Okay.
And I've had many people try this themselves, and it seems to work really, really well across a few different platforms.
Right.
So we've installed some Python requirements and packages, things that drive the configuration management and the requirements for NetReplica. We're going to now next install NetReplica. NRX is the tool provided by NetReplica. So this will just clone down NetReplica from GitHub and pull in some templates as well that are used to create our Containerlab file. To save us a bit of time, I've already deployed NetBox for us. So there's a lovely little Docker Compose based NetBox stack here. So if we hop over, you can see we've got NetBox up and running. We've got one site 14 racks, 18 device types, 20 devices, and 36 cables. So if we hop on over here, you can see that all our devices are pre-created. I've created a Sydney site, DC gateways, leafs, spines, everything shown in the demo picture is here. Devices have a role. So this is a key part of NetBox. So a leaf node for the Clo fabric, spine, super spine. You can also see we've got the various device models put in here as well, along with their network operating system under platform. NetReplica uses this to make sure that the correct device type is used in Containerlab.
And Tim, an important detail here. You said there were 36 cables that were represented as well. And in other words, NetBox gets down to that level of detail where cabling is also represented, which matters a lot when we're trying to stand up a digital twin like this.
Yeah, exactly. So if I hop into the Pod 1 Leaf 1 device, we're expecting this to be connected to the layer above. So we're expecting it to be connected to the spine layer. So interface 27 and 28 here are connected to spine 2 and spine 1 on the first Ethernet interface. We've also got the IP addresses that are on the interfaces as well. So when we run our configuration management after setting up the digital twin, that will use this information in NetBox to build the configuration that should go onto the device. So if we go forward and run NetReplica, it's connecting to NetBox and it's fetching the devices from the SID1 site, and it is building our topology. Now, I want it to grab only those 6 devices. So what I've done is I've used tags within NetBox, which is a very flexible mechanism we're going to use throughout this demo to drive how we go about, choosing which devices we're going to turn into a digital twin and choosing which devices we're going to change the configuration on. So I've added the demo tag to the 2 leaves, the 2 spines, and then down the bottom, the 2 super spines. The demo tag is used by NetReplica to pull those 6 devices out. So we can see now we have this sid1.clab.yaml file. So as Mark mentioned at the top, Containerlab configuration is all in YAML. So if we have a quick look inside here, we can see we have links at the bottom, but each of our device types are created. So we have a super spine. This is a IXR D3L 72 Nokia 7220 running SR Linux. So the SR Linux image is here. And then we've got the same for all the others. So we have the pod spine 1, spine 2, second super spine, the 2 leaves. Now, the key bit that NetReplica helps us with and saves us a lot of time and a lot of clicking and typing is generating these links for us. So remember how I said the pod leaf will have interface 28 and 27 connected to interface 1 of the spine? It's gone and done that for us. So it's all in the correct format for what Containerlab expects. As long as it's modeled in NetBox, then we're going to get an accurate representation here. So from here, we can Containerlab deploy, and this is going to stand up all of our containers for us. You'll notice there's an extra container there called Graphite. Graphite is a neat extra added by NetReplica. It's a visual web UI that allows you to see the topology of your network that is generated, and you'll see that it does match the image if you go through the demo yourself. So hopefully this won't take too much longer. All right, and there we go. We have our 7 containers, one of which is the Linux Graphite container, but we have our 6 containers running. So now we can just go in and SSH straight in. And we'll see, show interface brief, that we have our interface 27 and 28 up and enabled. And showing our LLDP neighbors shows that, we're connected to spine 2 and spine 1, and they only just came up. Now, other than that, there is no other configuration on this network. So if we do show network instance default, that's not actually there yet. So let's go in and push some configuration to the network.
So as in, Tim, all we've got right now is just a physical layout. Things are plumbed, they're talking to each other in that sense, correct. But there's no OSPF configured. There's no BGP, IBGP configured.
Yes, correct. So now we're going to push in configuration that's based on the information in NetBox. Containerlab adds a few nice extras for you just for the base configuration. So LLDP is enabled, and it enables interfaces that are connected to other devices But other than that, they don't do anything. There's no routing protocols. There's no policy. There's none of that. So what this step 5 is going to do is it's a Python script that talks RESTconf to the SI Linux devices, and it talks to NetBox, figures out what IP should be on what interfaces, what the role of device is, whether it's a leaf or a spine or a super spine, and it will configure OSPF and BGP for us. So if we run that real quick, it will generate a diff. And in this diff, we have all of our point-to-point interfaces. So putting in a /31 IP prefix, enabling the interface, creating our network instance. So this is where we go in and configure our routing protocols. So BGP between the loopbacks and OSPF. So OSPF to advertise, the loopbacks for BGP to discover. And it's generated, quite a bit because we've got 6 devices to push configuration to, but it should be done already. And so we go back into our leaf. Network instance default, OSPF neighbors, protocols, OSPF neighbors. We can see we have 2 OSPF neighbors that are up. We should also have 2 BGP neighbors. And we do. They've been up for 20 or 30 seconds. Yeah. And so it's the same thing if we go into pod 1, spine 1. We have 4 neighbors on the spine. Now, interestingly, because we generated the configuration from NetBox, and NetBox has information about the whole pod. Now, the pod normally has, I think it's 6 or 8 leaves in it. If we show the BGP neighbors for spine 1, we can see that we have the 2 neighbors to the super spines and the 2 neighbors to the first 2 leaves that are in the pod. But we also have, non-established BGP neighbors to 4 other leaves. This is useful because you can see that we've only created a digital twin of part of the network, but the configuration management script has pushed configuration to this device as if it was the production device, as if those 4 other leaves would be there. So it shows you that we are working on a copy or a near replica of our production network. So what can we do? What sort of change are we going to test? Well, I mentioned we're going to swap the IGP over.
And you said we're not going to take the IBGP sessions down while we do it, which I think is going to be a trick.
Correct.
So
keep an eye on these uptimes as you see them on the BGP neighbors. So this is in the spine. You can see they've been up a minute or so. Just keep an eye on that. We'll get to that bit. So what we're going to do is in NetBox, we can mass or bulk change, and we're going to change the tags. So I've selected leaf 1 and leaf 2 and spine 1 and spine 2. We're going to go edit selected and go down to the tag section. Now we're going to add an ISIS equals initial tag. So this tag has a value that the configuration management script knows about. What we're going to do is we're going to run the configuration script, and this will pick up these tags, and it will start to push ISIS into the network.
Okay, so while Tim's script is revealing some magic about the config management that's happening over there, I just want to touch on one feature that we literally just announced in NetBox Labs, which is branching and change management. You'll see that during the demo, Tim is making changes to NetBox, which are then reflected on the devices in the digital twin. In the real world, this could be a little bit tricky. You don't necessarily want to update your production NetBox with what you want, with what your devices may become, if for some reason you later reject those changes or you don't push them out to the network. So although there are many use cases for branching, this is a really critical one where you could, for example, stage a whole bunch of changes that should be included in some update to your network, keep them on a branch, run a digital twin like this and test it, push them even out to the network, and only when you're satisfied that everything has worked, you then merge that branch back into your NetBox again, which is great because now what it means is you don't pollute NetBox unless the thing you want to change has actually worked. And it also means that you're protecting what is in NetBox so that anything that's in the core database is always pristine or golden.
Well, Mark, you just described that's a GitOps kind of a function. If I was using Git and I was a software developer, I would be using branches and merge and so on. That'd be part of my version control. And that's standard operating procedure in that world. You're bringing that, or you have brought that at NetBox Labs into NetBox. And now I can make branches. And just as you described, I can merge them if they're good, reject them if they're not, and continue on from there.
You're absolutely right. And there's actually no surprise that our reference architecture looks like a big circle. If you think about traditional Kubernetes GitOps, it kind of is an actuator and a sensor. So on the one hand, you've got something that looks at Git, sees if there's a difference in Git between what you've put there and the infrastructure you're targeting, and if there is, it applies it. And then you've got another process on the other side which checks if anything's changed in the infrastructure, so you can find out. That's exactly what we're proposing here with NetBox and NetBox branching. When you update NetBox in a branch, you can then go and apply those changes to the network. But then also, up on the top left, you have this observability and assurance thread, which is always looking at the network to see, is what I think I have, i.e., is what's in NetBox actually matching what's in the network?
So while Mark was discussing branching, our configuration management script, I run it again, and it has pushed ISIS configuration into the network. It hasn't removed any configuration. It's just added the protocol to our network instance. Now, branching is key here because I might not want to add these tags to the production side of NetBox. I'd want to add them in a branch and then run my digital twin against that branch, so that just in case someone runs the configuration management against the network while I'm doing this, they don't end up stomping over production configuration while I'm trying to test something in the lab. So we're going to hop into one of our devices again, and we'll show you that there's ISIS adjacencies. Great. So on our pod 1 spine 1, we're only expecting adjacencies to the leaves. We didn't change the super spine configuration. We're just doing within the pod. So we have two lovely adjacencies here, and they're up. We'll go through and we'll check our BGP neighbors. They should still be up. We've not made any material change.
They still know how to find each other. Loopback that were established as
Correct.
their neighbor peering addresses, and they're still able to get there. Okay.
Yeah. So looking at the route table, we still have OSPF routes as well as ISIS route. We've added information throughout the table. We've not removed the reachability information that was being used previously. And the OSPF routes are still being preferred. So we've not made any change there.
The ISIS routes are just sitting there. They're ready to go. They're ready to as soon as the OSPF routes are withdrawn, the ISIS routes will go active.
Yeah, exactly. And if we'll just check on a leaf, we'll see that we have our two neighbors on our leaf. They've been up for 8.5 minutes-ish each. And we'll go back into NetBox, and we're going to change the tag. So once again, we're going to select leaf 1, leaf 2, spine 1, spine 2, and do a bulk edit. Now, this functionality is really neat because you can add in a tag, IS equals final, and we can also remove a tag. So we can remove the initial. What this will do is the configuration management will see that the ISIS equals final configuration tag is on there, and it will remove the OSPF configuration. So hit apply on that, and we're in our nice green ISIS equals final. And if we do check for OSPF configuration, there is none. We only have our ISIS configuration state. We'll go back here, and we'll run the configuration management again. So now we're expecting to actually see configuration removed. We can see protocols, OSPF is giving us a removed diff. And again, it's only affecting the two leaves and the two spines, so this shouldn't take too much longer. And there should be no changes for our super spines. Excellent. So we'll hop into our leaf. And if we do check for OSPF configuration, there is none. We only have our ISIS configuration. We shouldn't have any OSPF neighbors, but we should definitely have ISIS neighbors, or ISIS adjacencies, I should say, and they won't have changed. So now for the big reveal. We check our BGP neighbors. They've been up for 10 minutes. So we've managed to change the protocol that is used for the loopback reachability. It's now ISIS. As you can see, there's only ISIS routes in the table, no OSPF routes. And our BGP peers have stayed up the entire time. So the point of testing this was to see, could I do this change in production, and would I affect traffic if I was exchanging reachability information about an overlay network over my BGP peers? the peer hasn't changed. Routes have been withdrawn by BGP because the peers stayed up. So the overlay reachability during this change hasn't been affected at all. So because we're using the exact same software, SR Linux in this case, to run in Containerlab as is running on our real-world production devices, we're using the configuration management tool that we use in production. I can be pretty confident here that I could go into production and perform this same change, and I wouldn't have any odd side effects because it's all like for like. It's a replica.
Tim, one point of clarification. The configuration management tool that you use to hit NetBox, detect the tags that you were changing on the different objects, and then create a diff and new code for us, that is, well, you're showing it to us here, it looks like.
Yeah, it's just a Python script. So I wrote this from scratch for this demo. It uses PyNetBox, which is a really neat library to talk to NetBox, and then the requests library to talk RESTconf, which is over HTTPS, to SR Linux. This goes through and it talks to NetBox, pulls the information out, and then it will render Ginger 2 templates. So all the configuration here is driven from Ginger 2 templates. So you can see we've got super spline interfaces that uses another template. So for people that are used to using Ansible, for example, Ginger 2 templates are a fairly commonplace in network automation configuration. So this should be fairly familiar to folks. I suggest people, go around and have a dig through this tool. If, for example, you're using in your network Ansible or Salt or Noir or one of those other configuration management tools that's more suited to a production deployment, the same idea would work here. You can pull information out of NetBox and use that to drive your configuration. You could spin up a second instance to run within Containerlab because you can run not just network devices in Containerlab. You can just have Linux containers, and you can run your tooling within Containerlab as well. It's really, really flexible.
Another point of clarification, we talked about branches and the ability that NetBox has to do branching now, but we didn't actually use branches in this demo. If we had used a branch, how would this demo have been different, Tim?
Had we been using a branch, we wouldn't have gone in and edit to the devices on the base, NetBox branch or the main branch. What we would have done is we would have gone in and created a branch specifically for the changes that we wanted to test, and we would have added those tags to those devices within that branch. So for the production, main branch of NetBox, the demo tag might stay there, but we wouldn't add in these, change triggering tags. You'd want to run that digital twin and testing on the testing branch. And once you're happy that you want to go through with change, as Mark mentioned, you'd merge that branch back into the main branch of NetBox, and you'd then run your configuration management on your production network. It's so that you don't edit NetBox on the production side of things where you could cause impact, particularly when you're doing just lab testing. A nice isolated branch. As mentioned before, it's exactly the same as a GitOps type workflow that you'd use for some software development.
Yeah, the other great thing with branching there is if you imagine that this isn't a demo and you're actually trying to test out a change that you want to make to the network, normally that change is coming to you from some other tool within your business, whether it's ServiceNow or Jira or something. There's a ticket that has a business justification for that change you're going to make. And with a branch, you can make a one-to-one relationship between that ticket and all of the changes that belong to achieve the goals in that ticket in a branch. So it's a really nice logical connection there that maps much more easily back to internal change processes than writing directly to the main branch in NetBox.
Now, Tim, one more question for you. You're with Nokia. You showed us using SR Linux as the operating system of choice here and Containerlab, but I'm not limited to using Nokia images only within Containerlab. I can use any network operating system or any operating system in general. If I can put it in a container, I can run in Containerlab?
Pretty much. Containlab is multi-vendor. We've got support from most of the major vendors. You can run their appliances, their containers, even some network operating systems that run within virtual machines. You can put a virtual machine in a container and then run it within Containerlab. We've done that, for example, for our SROS platform. It's our service provider rather than data center network operating system. But we have support from all the major vendors, and when new virtual images are released, we've got a community of folks from the vendors and from the community that contribute, various kinds, which is the device types within Containerlab.
Device types and then Jinja templates, I'm imagining, are the other big thing I'd need to be keeping updated.
So the device types within NetBox would drive the kinds within Containerlab. So we've got various support here. What NetReplica does, which is the software that talks to NetBox and gives us that Containerlab topology, there's a little mapping file that you can use. So you can say that, when there's this particular device type, I want you to use this particular image. So if you've got an image that doesn't quite one-to-one match, you can do that, because some vendors don't do the type replication that we do. So you can see that we can put in a type so that when I bring up a Containerlab version of an SR Linux box, it looks like an IXR D2L or D3L. It has the correct number of ports. It has, a single line card or multiple line cards. So sometimes to get the most accurate digital twin, you've got to make sure that mapping is correct.
And then you showed us a demo with 6 devices. How big can I go? Am I limited by the platform I'm running Containerlab on?
Yep, pretty much. So I'm able to, on the server that I'm running Containerlab, I'm able to run this whole network. So 2 pods with 6 leaves, 2 spines each, the super spines and the data center gateways. But it's a fairly beefy server. So not everyone would have access to that. But the concept of a digital twin means that you can just reproduce a section of that. However, if you understand the value of building a digital twin and you take it to the next step and start to automate building a digital twin. So every time you create a NetBox branch, for example, you start to do some digital twin type testing, you can start to automate that. You can start to spin up a digital twin as part of a CI/CD pipeline and run tests on that. So from there, you can start to understand the value of doing automated testing before you make changes. And getting resources to justify that sort of thing starts to become a really good idea.
Another comment I'll make here regarding scale. If you don't have a box big enough to model the size of the network that you're wanting to model, but you have access to a Kubernetes cluster, Kubernetes would be a tool that you could use that would take Containerlab and span it across nodes in your Kubernetes cluster and give you some scale that way too.
Yes, correct. And Kubernetes is very neat in that regard, particularly if your business is already using Kubernetes. It can run on top, and it gives you access to build out topologies that are much larger than just a single server.
Well, thanks for the demo, gentlemen. This is cool because this feels accessible to everybody. And and all these tools, the basic NetBox and Containerlab, those are free. And of course, you can ramp up to paid versions of NetBox Lab for sure and get even more features and so on. Mark, if people want to get into NetBox because they haven't gotten there yet, where should they go?
As you go to netboxlabs.com, we recently consolidated a lot of the community resources in there, so it's easier to find now. And in particular, if they're new to NetBox, they should check out the NetBox Zero to Hero guide. That's a 10, 11, 12-part series they can follow. It goes from logging in all the way to I've got a whole network in there. That's a great place to get started. And incidentally, when you get to the end of that, you could point NRX and Containerlab at it, and you can make a lab out of the thing too.
NetBox community, Slack group, Discord, something like that?
Yeah, there's a NetDev Slack. If you go to netdev.chat, you can join in there. It's not only NetBox, but it's also a bunch of other open source network-related tools. Tens of thousands of people in there. Lots of fun.
Tim, same question to you. If folks want to dig into Containerlab, I know you had some of those web pages up, but give us those URLs.
Yes. Containerlab.dev is all the documentation for Containerlab. From there, people can also find our Discord community. This is where we've got a lot of people requesting different kinds, people contributing different kinds of new Containerlab images. It's a really neat place to be. We talk about Kubernetes and building various topologies. It's a lot of fun. So all the links are there on containerlab.dev.
And maybe I could just give one shout out for the third partner here who isn't present, Alex Bortok.
Yes.
At NetReplica.
Please.
If you go to netreplica.com, NRX is actually just one of the tools that we saw today that Alex has created. They're all open source. He also did the graphite thing. So big round of applause for Alex, and go check out netreplica.com.
Great stuff, guys. If you do the demo yourself and want to leave a comment for these guys, please do so on the video. And we'll see you next time with Video Bytes.